Okay, circular motion, that's a second topic. It's a short topic, and you will find most of the MCQs as compared to the structure questions. So the definition of a circular motion: when object continuously changes the direction, we call this motion as a circular motion. So what happened? Example, you attach a stone with a string or a wire, and you move this string. So what you will observe, the object will also move. But the movement of the object is continuously changing its direction of the motion. Direction of the motion is not fixed here. That's why we call that as circular or a motion in a curved path. What is the direction of the movement at point A? It is upward. But if I say at point B, it's towards right, towards left. At point C, it is downward. And at point D, it is towards the right hand side. So during the motion, during this movement, the direction of the motion is continuously changing. Whenever the direction of the motion changes, it means the velocity is also changing. Because velocity is a vector quantity, if I say the velocity here is plus 10, velocity here will be minus 10 because they are in opposite direction. So even though the magnitude of the velocity is not changing, but the direction of the velocity is changing. And whenever there is a change in velocity, we call that object is accelerating. So whenever object move in a circular path or a curved path, the object is always accelerating and there is always an acceleration. And whenever there is an acceleration, there is always a resultant force. So object move in a circular path or a curved path will experience a force, and the direction of this force is always towards the center. So the terminologies which are related to this circular motion, the first one is the angle. So one is called arc length or angular displacement. What is angular displacement? Like example, an object is there at position A. So an object is there at position A, it moved to position B. So A is the starting position, B is the final position. So the change in the angle moving from A to B, that change in the angle is refers to, or moving on in a circular or a curved path, the change in the angle is refers to angular displacement. So this is called angular displacement, and this angular displacement, it is denoted by a Greek alphabet, theta. So we use theta to represent this angular displacement. What are the units of this? It can be degrees, it can be radian. But normally when we measure this in radian, and the formula which we use, which relate the movement in a circular on the circular track, that's called arc length. And distance from the center of the circle to the extreme position, the final point, is known as the radius. So the formula which relate the arc length and radius with angular displacement is S is equals to R theta, where S is a arc length, the movement on a circular path, R is the radius of a circular path, and theta, you will always get theta in radian. This formula, theta is not in degrees, theta is equals to radian. Is it clear? The angular displacement?
Yes, sir.
You don't have to copy this. The slide which you will copy, I will let you know. Then how we can relate this angular displacement in radian and with degrees. So as we know, if we have a one complete circle, like object is starting at position A, and after completing its one rotation, one revolution, it returned back to the same position. So what will be the angle here in terms of degrees? The angle is equals to 360 degrees. And in terms of radian, that is equals to 2 pi radian. So the ratio, the relation between the degrees, angle in degrees and angle in radian is equals to 360 degrees is equals to 2 pi radian, or we can simplify this, we can say 180 is equals to pi radian. So if we want to change the radian into degrees, what we will do? We'll multiply by 180 divided by pi. And if we want to change the radian into degrees, if we want to change degrees into radian, then it will be pi multiplied by pi divided by 180. Means it is multiplied by ratio of pi to 180. So example, if we have angle say 2 pi and we want to convert this into degrees. So if we want to convert this pi radian into degree, what we'll do, we'll multiply by 180 over pi. So this is 2 pi multiplied by 180 over pi. So the pi will cancel with pi, so that's equal to 360, and that's obvious that 2 pi radian is equal to 360 degrees. Then what is angular speed? The angular speed, how much time it will take to change the angular displacement. That is known as angular displacement. Example, an object as at position A, it moved to position B on a circular track or a circular path. And the change in the angle in terms of radian, this theta is there, r is the radius, and the movement on a circular track, that's called arc length. So at position A, the time was 0, that's the beginning. When it reached position B, example, the time is equals to 10 seconds. So how much angle change or change in angle in a 1 second, that is known as angular speed, or you can also say angular frequency. So how we represent this? So omega, it is denoted by a Greek alphabet. Omega is equals to theta, the angular displacement, divided by time. So angle turn, that's in radian, we'll substitute, and the time example in this, it's 10 seconds. So the change in angle, if it was say pi by 4 and it took 10 seconds to change this, so this will become pi by 40. And what is the unit? The unit for angular displacement is radian per second, or it can be revolution per second. Revolution means when one complete rotation, we call that as revolution. Is it clear? The definition of angular speed. The angle turn with or rate of change of angle is known as angular speed. Any doubt in this? So copy this part, the angular speed. Then there's also another formula for this angular speed, and we can also relate the angular speed with a linear speed. How angular speed and linear speeds are related to each other. Example, say this is a top view, like this is a table, a round table, and you place a small object at the end of this round table, and you rotate this round table. So when you rotate this round table, the table, because it is turning, so what it will have angular speed, or it will have change in angle per second. But the moment when you rotate this table, the small object or the pebble is there, or any small object, it will move in a straight line or tangential to the curve path. So that will have a linear speed or a speed in a straight line. So there is a relation between the angular speed and the linear speed. how we can relate angular speed with a linear speed. As we have this formula for arc length, the formula S is equals to r theta. If I divide both sides by time or time interval, so what is this? S is the arc length or a distance divided by time. So distance divided by time, what we get speed or linear speed. And what is theta divided by time? It is equals to omega. So the formula which relate the linear speed with angular speed is V is equals to R omega. Is it clear? So object, when it is moving in a circular path, it will have angular velocity. The object which are associated with the large object or rotating in a system, they will have a linear speed in a straight line. So how we can relate the formula which relate the angular speed with linear speed is V is equals to R omega. Is it clear, this concept, the relation between the linear and the angular speeds? Any doubt? Yes, Hamza.
Yes, sir. No
Is
doubt.
it clear?
Yes, clear.
So the formula which relate the linear speed with angular speed, V is equals to R omega. So you have to learn this. Then there is also another formula for angular velocity, or which we also call angular frequency. As we know, omega, the angular velocity, is equals to angular displacement divided by time. What is angular displacement? If the object complete one rotation, the angular displacement is equals to 2 pi radian. So we can say 2 pi. And when there is one complete rotation or one complete revolution, that time is known as time period, which is denoted by capital T. Small t is a time for any change in angle, but capital T is a time which shows that there is one complete rotation or one revolution. And when there is one complete rotation or revolution, we call that time as time period, and the displacement or angle change in angle is denoted by 2 pi radian. As we know, frequency is reciprocal of the time period. So we have another formula for angular velocity. Angular velocity is equals to 2 pi f. Angular velocity is sometimes known as angular frequency, both having a same meaning. So you can use the first formula, or if there is one complete rotation, then you can use the second formula. So I want you to copy this part, the relation between the linear angular velocity and linear velocity, and the last formula. Just now we discussed this relation between the angular and the linear speeds. So whenever object move in a circular path, there should be a force which is acting towards the center. So different examples here are shown. Example, if you have a conical pendulum means the object is moving in a circular path as well as it is vibrating to and fro. That's a conical. If the object is only vibrating in one plane, that's a simple pendulum. But if normally we have conical pendulum rather than simple pendulums, in which is in a simple pendulum, our assumption is that it's not moving in a circular path or a curved path. But so in this case, it is having two motion, like there is a curved path, like if a pendulum is vibrating to and fro, whenever object is vibrating, there should be a force which is directed towards the center. So that force will be the tension due to the spring or tension of the spring. But if we have a conical pendulum, so what happened in a conical pendulum, the weight of this pendulum is acting down, and the tension, the tension in the string is making certain angle. So this tension will have two components. The component which is with an angle, this will be T cos theta, and against the angle will be T sine theta. So which component of a tension is responsible for the circular motion? T cos theta or T sine theta? Which component of the force is responsible for its circular motion? A conical pendulum. This
Cos theta, T
T
cos
cos
theta.
theta, because it is acting towards the center. So as it is acting towards the center, so the component which is acting towards the center is responsible for circular motion. Same thing if you have a vertical circle, like this object is moving and if this is a vertical circle and you tied this object with a string, so the string, the force of the string is responsible for its circular motion. Same way, example, motion on the turntable, an object is there on the turn. So example, a small mass is placed on the turntable and this is rotating or revolving in a circular path. So what is the direction? Because naturally what happened, the object tend to move away from the circular path. So the friction is the force which is opposing its motion. So if the friction is sufficient here, if enough friction is there, this object will remain in a circular track or it will move as same as a turntable. If friction is not sufficient, then this object will leave the track. So the mass move in a horizontal surface, the centripetal force is there, provided by the friction and the friction of the surface. Is it clear, this example?
Sir, I don't understand it.
This example, look, what happened if you have a circular track or a circular path, you have a table example, a circular table, and you kept a weight or a mass on this table and you're rotating the table you're rotating this table. So as you're rotating this table, there is a friction between the object and the surface or the table. What is the direction? Because natural tendency, if you are inside the car and you take a turn towards left, if you are taking a left turn, which direction you tend to lean? You tend to lean in opposite direction. You tend to move towards right. So what happens? Same thing if we are moving this object in a circular path or rotating this object, the object natural tendency to move away from a circular path. But what happened? The friction is always opposing the motion. So what is the direction of the friction? The direction of the friction is towards the center. So in this case, because the friction is directing towards the center or acting towards the center, so what is the centripetal force? The centripetal force is a friction between the surface. So centripetal force is a force which is acting towards the center, but this force is not having, like, it can be any kind of force depending on the example, depending on the question. In the previous example, there was a string like conical pendulum or a simple pendulum. So in that case, the tension in the string was a centripetal force. But in this example, the friction which is directed towards the center is responsible for circular motion. That's why friction force is a centripetal force. Is it clear?
Clear, sir. Yes, sir.
And same thing happened, like instead of this object, if you enter a roundabout, say this is a circular track, and you're driving a car and you're taking a turn. So when you're driving a car and taking a turn, there is a friction which is opposing the motion. So there's a friction backward here, and there's a friction which is towards the center. So the friction which is acting towards the center is responsible for the circular motion. Because the natural tendency of the car is to drift away from a circular path, but the friction between the road and the tire is responsible for the component of a force acting toward the center. So that's why, like example, if a road or if a track or a road is wet or any water is there or snow is there, then what happened? The friction will be small. As the friction will be small, the object will leave the circular track. So different example, the centripetal force is there. It depends on the type of example. Like if an object is tied or attached with a string, then it's a tension in the string. If an object is having a contact, like two surfaces are having a contact with each other, then the centripetal force is a frictional force. Same way, example, this is very common when a sharp bend is there. If there is a sharp bend, to assist this, the bank of the track is slightly inclined. Maybe you have noticed this. If you're taking a turn, this bank or the corner of a track is slightly bent. What is the reason? For example, if it was not bent, say this was a car and it is taking a turn. A car is, example, the direction is towards you, facing the screen or coming towards. So, and it is taking a turn, a circular track. So frictional force is there. The frictional force between the road and the tire is directed towards the center, which is responsible for a circular motion. But how we can increase this force? So what we can do, we can make this track or in a bit inclined or increase the slope. What is the advantage if we make a slope? The weight of the car is acting down and it is on the inclined surface. So as the weight of the car is acting down, this weight will have two components. The angle here will be same as angle here. So the one which is within angle is W cos theta, and against the angle will be W sin theta. So you can see here the W sin theta is also acting towards the center. The friction is there acting towards the center, and W sin theta is also towards the center. So this will be convenient to move the car in a circular track, even though the friction is small. So that is why, like a racing tracks are banked or sloped or inclined. The reason for that, so that the car can move in a circular path easily, even though the friction is not enough to rotate the object in a circular track. Is it clear, this example?
Yes, sir, it's clear.
Okay. Same thing, the planetary motion, the movement of the planets around the sun. So what happened? According to Newton's law of gravitation, both Earth and Sun are applying force on each other. So the gravitational force of a sun is responsive as it is directed towards the center. So Earth is revolving or moving in a circular path. How Earth is balancing? Because the force is towards the center, there is another force which tries to oppose its motion, that is called centrifugal force. If the gravitational force of the sun is more, then the Earth will come closer to the sun and it will eventually reach the sun. If the gravitational force is weaker, centrifugal force is more, then the track length will increase. Eventually, the Earth will go out from the orbit or the track. So in this case, the Earth is whenever object move in a circular path, it means there is always a force acting towards the center. The type of the force which is acting depending on the example or the condition which you are taking. So if two objects are in contact, then the frictional force is there, which is a centripetal force. If object is attached with a string, then tension in a string is responsible for circular motion. If objects are not in contact with each other and still they are moving, in that case, the gravitational force is responsible for circular motion. Is it clear?
Yes, sir.
So these are some examples which explain the idea of that whenever the concept is that whenever there is a circular motion or a motion in a curved path, the object should have a component of a force or force which is directed towards the center. So example, if there is a mass which is attached to a string and it is in a vertical circle, this is a vertical circle. The formula to get the centripetal force, if you want to find the centripetal force and centripetal acceleration, the centripetal acceleration, when the object is continuously changing the direction, because there's a change in direction, so there's a change in velocity, and due to this change in velocity, the object will have acceleration. We call that as centripetal acceleration. The formula to calculate this centripetal acceleration if you want to calculate the centripetal acceleration, that centripetal acceleration is equals to v square divided by r. There is a derivation, but derivation you don't have to learn. So directly the formula, that's why I wrote the direct formula. So formula to calculate the centripetal acceleration is v square divided by r. What is v? V is a linear speed, and what is r? R is a radius of the circular path. Then there is also another formula, as we know, v is equals to r omega. So as we know, v is equals to r omega. So in place of v, I can substitute r omega. So I can say omega. In place of v, I substitute r omega divided by r. So this will be a is equals to r square omega square divided by r. This r will cancel with r. So a is equals to r omega square. So this is the second formula for centripetal. If we know the angular velocity, we can use this formula. If you know the linear velocity, you can use the first formula. And whenever there's a centripetal acceleration, which is due to the change in direction, so there's a centripetal force which is acting towards the center. And the formula to calculate the centripetal force so this formula which we use to calculate centripetal, as we know, resultant force is equals to ma. So centripetal force is equals to m, and what is centripetal acceleration? Is a is equals to v square over r. So we can write v square over r. So we can write mv square over r. This is one formula. And the second formula, as we know, f is equals to ma. And the second formula of a is r omega square. So we can say centripetal force can also be r mr omega square. So there are two formulas for centripetal force and there are two formulas for centripetal acceleration. Is it clear? Is the small derivation? You don't have to learn derivation. The important thing is the formulas which you have to memorize. Copy these two formulas, centripetal acceleration and centripetal force. So if an object is moving in a circular path or a circular track, the force is always toward the center. So example, if you have a vertical circle, object is moving in a vertical circle. So what will be the centripetal force? So in this case, say object is there, which is continuously changing. Continuously changing the direction of the motion. So object is at position A. So when it is at position A, What are the forces acting here? Number one, the weight is acting down. And number two, the tension, because you attach this object with a string, so tension is also acting down. So tension is downward and weight of the object is also downward. Weight is equals to mg, so in place of weight I can write mg. So what is the centripetal force? The term centripetal force means the force which is acting towards the center. So which force is acting towards the center? The centripetal force, I can write Fc, which is equals to tension plus mg. Is it clear at position A? Because the weight of the object is acting down, and the tension is also because the force from the string. The tension is there, which is also acting downward. So both give a resultant force towards the center. As a result, like forces towards the center, the resultant force is a centripetal force. So I can say Fc, or centripetal force, or I can also say mv square over r is equals to T plus W. But if an object is at this position B, so the weight is acting down. So weight is not contributing to the centripetal force. The only force which is contributing to the centripetal force is a tension. So I can say the centripetal force is equals to tension. At position B. What about position C? The weight of the object is acting downward, and the tension, because you're holding the object with a string, so tension is upward. So resultant force should be towards the center. So it means the centripetal force should be tension minus weight. So tension minus mg should be the resultant force. And at point D, the weight is also acting downward. Weight is equals to mg. So the force which is required is a tension force, and that will keep the object in a circular path. So if I say I required a force of 30 Newton to move this object in a circular path, which point I should apply a minimum tension and which point I should apply a maximum tension? You have different points A, B, C, and D.
Minimum at B and D, and I think maximum at C.
Minimum at, basically, look, I mentioned I need a centripetal force of 30. So I need a centripetal force in all the cases. I need a centripetal force to be 30. But here already some of the weight is acting. Like example, if I say 10 Newton was the weight of the object. So how much tension I should apply here? I should only apply a tension of 20 Newton. So I have to apply a minimum force or minimum tension at A. And what about the maximum tension? I have to apply maximum tension at C. Reason for that, because the weight is acting down, so tension is acting up, and we need a resultant to be 30. So if example, if a weight of 10 Newton is acting down and I need a resultant to be 30, so how much tension I should apply so that I have a resultant 30? What should be the tension?
20. 40, sorry.
40. So 40 Newton should be the tension here. So at point C, we will apply the maximum force, and point A, we apply the minimum force. Is it clear?
Yeah.
And at this point, we just have to apply a force of 30 Newton. So whenever we want the object to move in a circular path, for example, if I say I have applied 30 Newton force here, here also 30 to move. Here we need a resultant to be 30, but because the weight is acting downward, so we have to overcome the weight. So here tension will be more and here tension is small at point A. So we will feel the object is heavier at C, and we will feel the object is lighter at Is it clear?
Yeah.
Yes, sir.
I will share another link when this will end.